final concept that we're going to look at here are the common internal and common external tangents. I mentioned these in chapter 4 and that we would come back and do some calculations with them later. Okay, so here we have a common external tangent for x is x. Okay, and here in blue we have a common internal tangent. All right, so what I'm going to do is talk you through the process for solving these. Okay, and the process is pretty much the same thing. Okay, you just need to be able to distinguish which is it that you're trying to find. Okay, so if we're trying to find this common external tangent, which is the length from this tangent segment to this tangent segment, or this point of tangency to this point of tangency. Okay, so step 1 in both of these is you're going to draw in your radius to the point of tangency. Okay, now remember from chapter 4 that when a radius intersects a tangent line, it intersects at a right angle. So these are going to be squared off here. You're going to have these 90-degree angles here. Okay, if I label the pieces of information, so I have a radius of 7, a radius of 14, so my smaller one 7, the larger one 14, and I have a distance of their centers, which is this dashed line, is 27. Okay, so taking that information right there, I'm going to build off of it in order to solve my problem. Okay, and so again, when you do the common internal tangent, you're going to go through this same process. Okay, what you're then going to do next is you're going to extend the smaller circle's radius until you can square it off with the larger circle's center. Okay, meaning if I form a right angle at this larger circle and I extend my radius here, I'm going to create a right angles, giving me a total figure that's a rectangle. Okay, and the whole reason for that is I'm looking for this little corner of the rectangle here. Okay, and if I pull that corner out and identify the pieces, so here is my 27. Notice because this is a rectangle here, my opposite sides are equal, so this measure is x, and my opposite side here is equal. This measure is 14, which means if this whole thing is 14, what's left for this portion here? 14 minus the other radius 7, so that leaves a 7 for that leg. Now notice I created a right triangle here, so I have 2 of the 3 parts. I can find the third part by using Pythagorean Theorem. The sum of the squares of the 2 legs, x squared plus 7 squared, is equal to the hypotenuse squared. If I subtract 7 squared from both sides and then extract my square root, I get x is equal to, and in the exact form would be 2 root 170. And if you were identifying the decimal equivalent here to 2 decimal places, I'm looking at 26.08 as my missing length x, my common external tangent. If we follow those same steps to solve this, so now my common internal tangent is this length right here. Okay, so I'm going to draw in my radius to the point of tangency from each of those circles. Remember, the tangent intersects the radius at a right angle, so I'm going to draw these as right angles here. And then I'm going to label my information. So small circle has a radius of 7, a larger circle has a radius of 14, and the distance between these centers, which again is this dashed line here, is 27. Okay, once I get to that step, I can now extend the radius of my small circle to square it off with my larger circle. So if I create a right angle here, and I extend this radius until I can square it off, what I've created here is another rectangle. Again, this is the full-length rectangle here, where my opposite side is y, my opposite side here is 14. And the whole point of doing that is it allows me to draw this whole right triangle right here. So this is the right triangle I'm going to be working with. So again, I'm going to kind of pull that out. Here, I have a length y. I have this hypotenuse of 27. And this whole length here is this portion that's 14, plus this remaining portion, the radius of the center, which is 7. So this whole length here is my leg of that triangle. Once I created that, I can use Pythagorean Theorem now. Y squared plus 21 squared is equal to 27 squared. Subtract 21 squared from both sides. Extract my square root. and I get y is equal to, again, if I find my exact answer, it winds up being 12 root 2, and my decimal answer, 16.97, if I round it to 2 decimals.